Alright, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Blue Block, aka First Period. And in this video, we're just going to be working through some similar ideas that we had from before. So again, we combined like terms. When we were working with expressions, and it's going to be the same idea, except now we want to make sure that we're balancing our equations. So, just a couple review ideas. We could say a term. We could say a term is a number, a variable, or a product of numbers and variables. So again, those are just some of the vocab ideas that we have on our word wall words, but we're just kind of recapping from before. And then it says, we could say like terms. Like terms. Again, those are the ones that we can combine. So if you've been hearing what I'm saying before, we're saying you can't add apples and oranges together. You can group them into their own groups, but you want to make sure that they are separate. And then lastly, a constant. A constant is a term without a variable. That's just a number, right? So you know how to add those together very simply. Okay. Also, please remember, all constants are like terms, meaning you can add those together. So like on that Unit 4 test that we had, that problem number 5 where it said 7 plus s plus s plus s plus 22, very simply was 4s plus 29. Same idea. Again, you can use your Desmos calculator to check now. All right. So, for example, you want to be able to either highlight or maybe box in your variable terms, and then you can circle your constants. And so the reason why I do this is it helps you determine, hey, what is in common. So as I'm reading over this, it says negative 2x plus 6 plus 5x minus 2 equals 31. And so we can say, all right, I can highlight or box in my variable terms. And so I'm going to say, all right, negative 2x, and then a plus 5x. Those are our variable terms, and then we can circle our constants. All right, that kind of helps us work on that one side of the equation. If you find that it is helpful to draw these out, please do. Again, if you would like to draw out the picture, you certainly can. However, we're trying to maybe move away from that. We're trying to group these together first. So can anyone tell me what would be negative 2x plus 5x? What do you guys think negative 2x plus 5x would be? All right, 3x, very good. So we have 3x. And then what would be 6? What would be 6 minus 2? 4. All right, so we have a plus 4 here. Again, bring down everything else, so we have equals 31. And if you notice, this is a simple two-step equation, just like we've been doing. So again, you can draw your training wheels, railroad tracks, whatever you want to call them. And what do you guys think? Let me actually see. Do I have? Let's go from the deck of tricks. Sure. Nicholas, can you help me out? If our equation is 3x plus 4 equals 31, what would you like to do first? So you always want to add the opposite, and so how could we get rid of the non-variable terms? Meaning, how can we get rid of this plus 4? That's okay. At least you're being honest. I appreciate that. Well, I'm here to help out. So again, to refresh your memory from Friday, again, we say we add the opposite. So what would be the opposite of a positive 4? There it is, negative 4. So I'm going to add a negative 4 to both sides. Because whatever I do to one side, I do to the other. Again, this cancels out our 4 on the left. And so the 3x comes down. So we have 3x equals, and then 27. Everybody all right so far? Hopefully. All right, so now it says you have 3x equals 27. again, you want to make sure you can always divide by the coefficient, meaning we're going to divide by 3 to both sides. We're going to divide by 3, divide by 3. Be very careful. A lot of people have said that this is 0, which it is not. Again, 3 divided by 3 is 1, and so we have 1x equals 27 divided by 3 is 9. All right. So I'm claiming that this is my answer. How can I check to make sure this is true or that this is correct? I could use a calculator. So I'm going to use a back substitution. I'm going to say that we substitute in x equals 9. So we substitute that into the original equation. So anywhere where we had an x, we now have a positive 9. So let me do this. Let me say, all right, I have a negative 2 times 9. I have plus 6. I have plus 5 times a positive 9 minus 2. And our goal is that should equal 31. So again, you can use that Desmos calculator to check, but we can also use our order of operations to make sure that is the same value. So again, working left to right and using that order of operations, I'm going to start by using negative 2 times 9 is negative 18. Everything else stays the same. Then I can do, I can do 5 times 9, that's going to be 45. 45. Everything else stays the same. So I can bump this up a little bit. Since we're on addition and subtraction now, again, you want to work the furthest to the left, just like you're reading a sentence. And so we can do negative 18 plus 6. That's going to be a negative 12. Everything else stays the same. Same idea. Negative 12 plus 45. That's going to be positive 33. And then we have 33 minus 2. That does equal 31. So we are good. Again, make sure that you can get the same result for yourself.
Mr. Shane, can I make my map testing real quick? Or need one more?